Alright, so this is the sig test problem called double angle non-special. And so the main part we want to look at is, first of all, what is the question asking for A, which is sine 2 theta. And for sine 2, we put 2 cosine sine, so that's all multiplication. And then for B, it's the cosine of 2. We have 3 possible rules to use. We got cosine squared minus sine squared. Then we have 1 minus 2 sine squared. And 2 cosine squared minus 1. Now we will be using only one of each of these lists. So for cosine we would be using the first one, and for sine, obviously the only one there. Just those two. So now we just copy down those rules, because you'll have to do this for each problem, just so you can fill in correctly. It leaves less room for error. So copying that one down. And the next one we're using that rule, not the other two, because we need both cosine and sine in it. Alright. Copying them down, now we look over to our other information given in the problem. Before we even start filling anything, we look at quadrants. I usually draw a circle just off to the side, and what quadrant 3 is telling us in our problem is that our triangle is in the third quadrant. So here's 1, 2, 3, 4, and our triangle is somewhere in the third quadrant. Not a specific angle, it's not a pretty angle. We're not finding angles. So I just shade out the parts we don't need. That's where triangle is located, in the third quadrant. Now we look over to our other given information, which is sine -5/13. We draw a triangle with this information. The negative sign of 5/13 does not matter. We only look at the 5/13 for our triangle that we're gonna solve for right now. So I write down SOHCAHTOA, just in case you need the visual, but most try to memorize that. I even on paper sometimes write it down. So we have sine, and we're gonna just write sine, which is opposite, which is the 5, which is the 5 is over the 13. Hypotenuse is the longest leg of our triangle, and we're trying to find our other angle. So we use Pythagoras theorem, which is a squared plus b squared is equal to c squared. Now, to find our missing side, we just plug in. 5 would be our A, or B, does not matter. B is our missing angle, side, keep saying angle, and 13 is our hypotenuse. Don't forget the squares, use your calculator, or if you know how to square numbers, 5 squared is 25, plus b, which is the one we're trying to find, is equal to 13 squared. So I'm going to punch that in. 169. So we know that to get b by itself, we get rid of the numbers, and get b on the one side, so 169 minus 25, which is 144. So b squared is 144. Pythagoras theorem, to get rid of the square signs, we get the square root of 144, which is 12, if you could memorize that, or use your calculator if needed. Okay, so our missing side is b. We got all our components. Now we can actually move over to the problem. Yep. So let's do A first. With our rule that we wrote down, let's plug in the 2 stays multiplied by our cosine. Our cosine was not given to us, so we need to find it, which is a fraction, using our SOHCAHTOA that we wrote above, using our information we actually found completely. So I set it up like this because they're going to be fractions. Our cosine is adjacent over a hypotenuse, and to our symbol, our adjacent is 12 over 13. And you could just plug right in the sign because it was given to you. Now, this is where we need to take in consideration because our sign is negative and they give the information of the quadrant because we need to make sure we're getting it correctly. We need to get the cosine. Is it positive or negative? In our quadrant 3, our cosine is negative. So do not forget that. We need to mark that each time. That's what the quadrant is there for. And if you look at signs, our sign that was given is negative, and we look at our triangle in the quadrant, the sign of our triangle we put there is negative. So we are doing it correctly. It's in the right one. So always remember that. And now we just multiply all the numerators, which is 2 times negative 12 times negative 5, which is 120. All over all the bottoms multiplied. So 13 times 13, 169. And sometimes the fraction can be simplified. You always look if you can simplify it more. I do not believe that it can be simplified more. That both will not make a decimal because it says leave fractions, so that would be your answer for A. Alright, so now we're moving on to the cosine. 2. Once again, we plug in our cosine and sine where it says, but these times they have the squareds. What you need to understand is that when we plug these numbers in, it would be squared. And if our cosine and sine are negative, a negative squared would be positive. So you don't even have to write it ever as a negative squared. You could just write it as a positive squared if you want. So I'm just filling in where our sine and cosine are. Don't forget the squared signs if you're writing it all out like this. So when the squared is on the outside of the parentheses, you square the top and the bottom. So you see that negative 1 squared is equal to 1. So as I said before, you don't even have to write it negative. You could erase it or just as a visual. See why you change signs. So now I'm just going to multiply the top by itself, which my calculator wasn't programmed right, so I'm just going to change it to a positive, since we all know that a negative squared would turn to be a positive. I'll make some more room. So right now what I did was the negative 12 squared, that was the top. Now I have to do the bottom, which is 13 squared, which is 169. So now we move up to the sine. Once again, I'm not going to even punch in the negative 5 squared, I'm just going to punch in 5 squared, since it'll be a positive number anyways. 25 over 13 squared, which is the same as before. Just rewrite 169, or if you want to confirm with your calculator. So denominators are the same, so we do not need to manipulate one or the other. So we just do the numerators minus each other. And the denominators stay, simple addition, subtraction of fractions. This also cannot be simplified, so that would be your answer. But always check if it can be simplified, because that is what is asked in the problem. Sometimes. Now we're going to move on to number 2. Once again, we're going to go writing out our sine and cosine equations that we know we have one option for sine and only one option for cosine out of the 3. So I'm just copying it back down as before. And the cosine, which is the first one. Alright, now let's move on to the quadrant, because that's the next thing we can look at. We draw a circle, or if you can keep that in mind, but starting out, I'd recommend a circle just to visually see it, where our triangle is and where our cosine and sine would be positive and negative. Our triangle is in quadrant 2, and we're not using any of the others, 1, 3, or 4. Just remember 1, 2. Now we gotta fill out information for our triangle as we did above, using our Pythagorean theorem after we draw our triangle, so I'm gonna draw it real quick. I'm going to put the theta in just the right corners where I usually set it. Once again using SOHCAHTOA, but we're using cosine this time because our cosine is what is given to us. I shall rewrite it so I don't have to keep pulling it up. Alright, now cosine is adjacent over hypotenuse. Our adjacent, which is 5. And our hypotenuse, which is 9. And now we're going to try to find b, just as we did above with the Pythagorean theorem. So, after plugging all the numbers in, you should get b squared is equal to 56. So to find b just by itself without the squared sign, we gotta get the square root of 56, but it's not gonna get you a nice number as the square root of 4. So we have to simplify it, because that is what our problem is asking us. Any information found, get the exact simplified form. So to simplify the square root of 56, since it won't be a whole number, we write the number and do a factoring tree. With the highest numbers that can multiply into 56, which is 8 and 7. 7 does not factor, so let's go to the 8, which is 4 and 2. 4 can still factor some more, so we go into 2 and 2. And now we have a pair that we can actually take out of our square root. So right now our square root consists of 2, 2, 2, and 7. We could take out 2 of the same number, which is considered a pair, and the leftover numbers could be just multiplied together. So to rewrite it is 2, that was on the outside was the pair, and whatever left over could be multiplied back together. You do not need to write 2 times 7. So b in its simplified form is 2 times the square root of 14, and if you want to double check that, the square root of 56 is that, and punch in 2 times the square root of 14, which gives you the same exact decimal. So that way, you do it right, and that's the simplest that can go. Alright, now that we found our b, we just write it in to complete our triangle. So with these, we can now go on to our problem with the rules and start plugging in. So 2 is carried down. The cosine, which is already given to us, we can just rewrite with the negative, -5/9. And now sine, we need to, no, you can double check cosine because it's given to us and it's in quadrant 2, so it'd be negative. Now sine, we need to take in consideration because that's not given to us. It is in quadrant 2. So our sign would be positive. Looking at our triangle, our sign is opposite in its simplified form, not square root of 56, 2 to the square root of 14 over hypotenuse. So now we can punch that into our calculator, all the tops multiplied by each other. 2 times -5 times 2. And we do not touch the square root of 14. That is like mixing apples and oranges. Keep our apples together, which are the solid numbers, and just bring down the square root of 14. That does not simplify together. You do not multiply -20 times square root of 14. Just keep it as that. And the bottom is multiplied, which is 9 times 9, 81. Once again, that would be the simplified form, so you would end there. But sometimes there are times it could be simplified some more, so make sure you always check it. Now we are on b, which has squared, cosine, and sine. So it does not matter if we use positive or negative, unless you want to visually see it, because a negative squared, once again as in problem 1, is positive. So I'm just filling in cosine squared minus the sine squared, which we found out, remember, simplified form. And all of that squared. So distribute the square, 5 squared. Now we have a not pretty number to square. Let's go over to the side and clarify this. But we see the easy one is 9 squared because it's 81. But the 2 to the square root of 14 is not easy to square. Not a pretty number to just see, to punch into your calculator. So we know from our triangle that we simplified 2 to the square root of 14 is square root over 56. So I'm going to rewrite it here. So which one would be easier to square? put the first one squared, or 56 one squared. Because 56 to the 2, the square root to the exponent would actually cancel. So you're left with 56. If you use the long way, you have to square the 2 and square the 14. So 2 times 2 is 14 times what square root of 14 squared is. So 4 times 14 is 56. So same number, but I recommend going back to your original square root, the one that you didn't simplify, so you could just cancel out the exponent and the square root sign. So it'd be much easier than doing 2 more steps. So I'm going to just write it in. 25 minus 56 is negative 31 over common denominator, written as 81. So we double check if that can be simplified. No, nothing with a decimal. So here's problem 3, correct answers, and I just wrote down the rules here to keep in mind. That I looked over to what quadrant it's in 4. So I visualized a triangle, did Pythagoras theorem to find the missing angles, and we simplified square root of 48. Make sure the missing side that were not given to us, like in this case cosine was given to us, so we had to find sine by ourselves, is negative, because in our quadrant our sign is negative and you multiply the top and bottom, and that would be your answer. Then you plug into our cosine, so it'd be 1 squared over 7 squared is equal to the much easier to square this, the non-simplified square root of 48. Negative 47 over 49 would be our answer, and that's it.